So now we're going to do the pre-calculus final review. That's the non-pair part. And so the first thing asks for the symmetries. And for the origin, we change negative x for x and opposite of y for y. And two negatives make a positive. So we're back to the beginning. So that's a check. For the x-axis, we do x times negative y equals 5, which is negative xy equals negative 5, which is not the same as the beginning. So that one's not included. For the y-axis, we got negative x times y equals negative 5. Well, once again, that's just negative xy equals negative 5, which is a no. For the line y equals x, we change x and y. So, since order does not matter when we're multiplying, we got that one. The line y equals negative x, we got negative y times negative x equals negative 5, which gives us xy equals negative 5. So this is my answer, this is my answer, and the origin is my answer. When I have, in problem number 2, this is actually problem number 3, if I have an even problem, I'm looking for anything that is symmetric to the y-axis. One example would be I realize I didn't draw that too well, but as you can see, if I fold this over, it could go that way. If I'm looking for an odd function that is symmetric to the origin, and it could look like this, and that's an odd function. When I have x minus 2 squared, what is the transformation? Well, because we have minus 2 inside the parenthesis, that means we're heading to the right 2. If we have the square root of x plus 6, the plus 6 is outside, which means we're going up 6. For this problem, we're trying to find the inverse. We switch x and y, and then we try to solve for y. So I subtract 7, and then I'm going to take the square root. And remember, when you take the square root of both sides, you want to have plus or minus the square root of x minus 7 equals y minus 3. Now I'm going to add 3 on both sides, which means my answer for the inverse is going to be 3 plus or minus the square root of x minus 7, which could also be written as plus or minus the square root of x minus 7 plus 3. So if this is a multiple choice test, either one of those answers is good. They won't both be choices, but you're looking for one of them. Now, the second part says, is this a function? Because of the plus or minus, this is definitely not a function. Alright, for this problem, if I graph y equals the absolute value of x plus 2, the graph is going to look like this. And you can get that from plugging it into your calculator. Remember, to get to the absolute value, it's math number 1. Anyway, since this is at the point 0,2, this is at the point 1,3, and this is at the point negative 1,3, to graph the inverse, the point 0,2 will now be at 2,0. The point 3,1 will now be at 1,3. Sorry, the point 1,3 will be at 3,1. The point negative 1,3 will be at 3, negative 1. So this is the inverse. And if they asked again, it is not a function, but in this case they did not ask. For the next problem, we're given x if x is less than or equal to 1, 2x if x is greater than 1. So when I plug 1 into this problem, I get the answer of 1. When I plug 1 into this part of the answer, we get a 2. Because these numbers are different, what we have here is a jump, discontinuity. In problem number 7, if I graph 1 minus x cubed on my calculator, I get something that looks like this. The limit as x approaches, we have the limit as x goes to negative infinity, which is the left-hand side, and that's at the top of my graph. Then we have the right-hand side, where the limit as x goes to infinity, not limit. Y goes to, well, it's down there, so it goes to negative infinity. Okay, for problem number 8, I put it into my calculator, but I need to change my y min to equal negative 20 so that I can see the whole picture. So it goes like this, and then it goes like this, and then it goes like this. So first we need to know what these two places are, and all we need to know is the x values. So the first thing I'm going to do is I'm going to find the minimum, and remember I'm going to do left, then right, and then for guess I won't do anything. And it tells me that the minimum is at x equals negative 2, the y equals negative 20, which I'm not concerned about. When I get the max, I'm once again going to do first here, second here, and then guess. And it tells me that the answer is at x equals 1. So it is decreasing when x is less than negative 2, when x is greater than 1, and it's increasing between the two numbers like that. Alright, this next one we're looking for and identifying the extrema, which means the mins and the maxes. So we're just going to plug this into a calculator exactly like we did for the last problem. But this time we are going to get one that looks like this. That was awful. Let's try that again. It looks like this. And so I need to know this point and I need to know that point. So when I find the maximum, we go first here, then here. And we find out that the maximum is at 1, 4, and this is a relative max. And this point down here, we find the min. We're going to do first over here, second over here. And we find out that it is going to be at the, and remember when you see an e to the negative whatever, it should be 0, so my point is at 3, 0, and that is a relative minimum. Alright, the last problem for this one says f of x equals x over x minus 1, and we want the asymptotes. So first I'm going to do the vertical asymptote, which is when you set the bottom equal to 0, which means x is equal to 1. For the horizontal asymptote, this has an exponent of 1, this has an exponent of 1, so we take the numbers in front, so we got y equals 1 over 1, which is y equals 1. And so here's my vertical asymptote, here's my horizontal asymptote, and the graph goes like this and like that. And that will be it for this first part of the review video.